Hello, just wanted to make a quick video to show some of the analytics that could be done with the data that you collect using Hype to make and take your surveys. I want to talk about Iceberg really quick. Iceberg is the solution that's used to store all the data that we collect. Um, what's happening when you're making and taking a Hype survey is that data is going into the immediate app-facing database, which is DynamoDB. What DynamoDB allows you to do is have a really quick, snappy user interface, quick retrieval of data, makes it possible to have a multi-region solution. So if Amazon goes down in the east, you can still be running in the west, so your customers aren't impacted. But that data is automatically being pipelined from DynamoDB into Apache Iceberg. And what Iceberg lets you do is make your data available to different types of databases, different database vendors. So if you think about like the old days with Oracle databases, that data was stored in a proprietary format. You could only query that data, work with that data if you had Oracle licenses, which were incredibly expensive. With Iceberg, you keep that data in inexpensive storage, and it can be used for with different engines: Redshift, Athena, Snowflake, Redbricks, others, and just different types of analytics operations: MapReduce, AI, machine learning, statistical modeling, just basic ad hoc SQL queries. Makes it nice. And what I'm using to work with that data right now is Amazon SageMaker Unified Studio. And I'm going to demo that right now. So let's go into my notebook. Um, and I want to show you some of the data that we've collected. So I've got face liveness data captured here, facial recognition data, text analysis, profile information coming from a social login providers, answers to the survey questions, all that stuff. So right here, what we're looking at is SQL query, right? So you can see if you're someone who works with NoSQL, relational databases, you can see this is regular SQL. So now we're in the analytics domain. We're not stuck using DynamoDB to do analytics, which sucks. We can actually work with a tool that makes sense for the data domain. So right here, we're just looking at string data, just showing you that this data is captured. What I will really want to show is that every version of every question is saved. So for instance, this age answer right here, you can see versions 1, 2, 3, 4, 5, 6. And you can see I've given different answers to those questions. So the plan for Hype is to do all the screening in Hype using Hype's screener library so that we capture every answer. We are forcing them to log in with social auth, so we have a real ID to attach these answers to. And so now, as part of the quality process, we could see for a screener process like age, gender, occupation, things that shouldn't change too often. We could see, is their answer changing too often? And we could also make this data visible to the researcher when they're doing their final analysis of their final results. Real quick, that's part of the artificial neural intelligence that I want to build with this product. I want to put all this information in front of researchers, force researchers to mark all their respondents as good or bad, and use that as the training on all this data and metadata being collected to over time produce what I think could be the best tool for detecting good or bad panelists. More on that later. Show you some text analysis. So right now I have it so every text answer has text analysis applied to it. Might just want this to be applied to open ends, probably going to make it optional to the survey programmer, which questions they want to have this applied to. But this is a lot better than the old school text analysis in the industry where it's just counting the number of words and just looking if any bad words were used. So let me show you some of this here. One thing it does is it'll detect the actual language. So you can see here, for the most part, I've been detected as using English, but if I was writing Chinese, Russian, it would detect that. It gives a score here for how sure it is of the language. Sentiment, this is detecting, are you angry? Are you neutral when you're typing these answers? It also gives grades for all different types of sentiments, like how toxic Was your answer? Were you very graphic? Were you harassing? Were you using hate speech? Were you insulting? Were you using profanity, sexual language? It gives a level of confidence for all those different types of things. For all the different parts of speech, it'll count how many appear. So nouns, verbs, adjectives, adverbs. It's actually about 10 to 15 parts of speech that it'll detect. I have primitive language skills. You can see I use a few nouns and verbs, adjectives, adverbs, not a lot. It also detects the key phrases. I haven't broken this out in this query, but if I would talked about my shoes a lot in a text answer, it would point out, it would bring in shoes as a key phrase. Face liveness, I did demo this on the last video, but you can see right here, what's being shown is, are you live or not? So in all the cases I've tested, I was always just using my real face in front of it. Had I put a picture in front of the camera, it would have detected that I was not indeed a live person, and I would have gotten a low grade here rather than a good one. So all these AI tools work in a similar way. They provide a level of confidence that something is true or not, and then it's up to you to decide what your threshold is for accepting that level of confidence. So for right now, I'm just using a threshold of 50%. As I learn how good this face liveness tool is, but I'll probably bump that up. Since we're capturing a face image, we can do facial analysis on it. And so here, just showing you what kind of data points are there. Age range, age low and age high. So I'm older than this, so that's comforting. It's detecting me as a male with a high degree of confidence. So, I mean, can you blame them? Whether or not you got a beard, I don't have a beard, but I don't shave often. So this seems correctly. No mustaches. Could give you a level of confidence if this person is wearing glasses or sunglasses. And also give you a level of confidence for, is this person angry, calm, confused, disgusted, fearful, happy, sad, surprised. I'm not sure how good these indications are. I keep trying to smile and look happy, and it keeps saying I'm sad. Maybe that's just me. Maybe I'm too emo. And here I want to show you all the metadata that's being captured. Like, this information is captured with every answer. So every time somebody answers a question on the page of a survey, all this information gets captured. So think about some of the quality tools that are in place right now in the industry where, at the start of a survey, it gets one network request to kind of judge, is it a good or bad panelist? And I think that's one of the major faults with today's quality services is that's just not enough information. So what Hype can let you do is, with every single answer given, capture a lot of information and do analysis on all that information. And it's going to build up a huge data set. And again, going back to forcing the survey researcher at the end of their study to mark all the respondents as good or bad. Put all this information in front of them as far as device type, where they've come from, the quality of answers they're given, the AI analyses, and say yes, good or bad, each respondent. And that's going to be the training on all this data to produce what I think is going to be the best quality tool for good or bad respondents in the industry. So real quick look at the metadata that's collected with every single answer to every question. Transfer time in milliseconds. This is how long it took for the data to come from their client to Hype's backend. And so this includes the time from behind a VPN. So that's not something I'm aware of in any tool. So this can give you an indication. VPNs are a false signal. Some of the quality tools out there see VPN and say no, they're probably bad. It's not correct, because a lot of people use VPNs to protect their digital identity online. So there's lots of good people using VPNs. So it's not a true fraud signal. So yes, the indication yes, no, a VPN is something you want to think about, but capturing this time can tell, hey, this person is in a different country. This person's on another side of the globe. Anyways, time between requests gives me, let's skip that one. This is delay time before the first answer, so when the survey page loads. how long is it between the loading of that page and when they start typing or moving their mouse around? That gives you an indication as to whether or not they're actually reading questions. This JA4 fingerprint, this is better than the digital fingerprints being used. This gives you information from behind the VPN. User agent, this is information about the operating system, the browser being used, the versions. Geography, I could tell based on IP, their latitude and longitude for latitude, longitude, radius targeting. Their postal code, their city, metro code, country name, the device type, and also capture all the client events that are happening while they're answering their survey questions. So mouse movement, key clicks, are they copy pasting? Also the timing of each one of those events is captured. So how long in between their key clicks. Let's just look at some of the data picked up here. So IP address, this is the JA4 fingerprint. This is the origin they're coming from. So this is my test environments. But let's say we're embedding hype surveys in third-party websites. We'd see the website they're coming from. Here's the device, Apple, Mac, and iPhone, or whatever I'm using. OS version detection is wrong. That's just part of technology today. These browsers aren't sharing the information you need to actually detect these versions. But the type of version is correct, the type of OS is correct, the type of browser is correct, the browser version is correct, the rendering engine in the browser. Yeah, so here's all the geography. So I've been testing from home, so you're always going to see similar latitude, longitude, postal code, city, metro code, country region, country name, my device type, am I on a mobile, desktop, smart TV, and I haven't broken it out here, but these are all the events that are happening while they're taking key click events, mouse events while they're taking a survey. So right here you could see, without asking a single question, we could have location. Using that facial analysis, we can know, are they very likely a real person, a rough age range, gender with good level of confidence. So age, gender, location. Right there, without asking a single question, you can target pretty well. Also, bringing all this metadata, you could have you're going to be building up this ANI, this artificial intelligence model, to over time, with the help from the researcher, doing the training on this data set, marking each respondent as good or bad at the end. We're going to be able to tell, are they good or bad panelists based on this data. Also capturing every version of every answer to every question. Let's see if I get to that again. Right here, these version numbers. Every time you answer a screener question, I'm capturing it. It's attached to a real ID. In this case, my GitHub ID, but if I was coming from Facebook, it would be associated with my Facebook ID. You could build up real profiles over time. You can make this data visible to researchers at the end of the study. I think that brings a lot of value. That's that for now.